Hello everybody, I'm Sebastian. I'm working for Flanders Hydraulics Research in Belgium, and together with other 5 partners, we developed many tools in this project in order to improve coastal adaptation to climate change. And we are focusing on the sand dunes located in the Interreg 2 Seas area. This area can be seen in a brighter green in this map. And of course, my colleagues will present more about these tools, but I will focus on the Endure viewer. This viewer was built by Deltares at our request, using our data and our specification. Currently, the viewer is hosted by Vlis, which can also make changes if needed to the viewer. Why do we build this viewer? Is first of all to improve the capacity of the stakeholders to manage the coast, the sandy coast with the dunes. But also we build it as a communication tool. It's easier to communicate with a graphical interface, what can happen in case of sea level rise, and what is the state nowadays, and which kind of data do we have regarding the biology of the dunes and the morphology of the coastal area, etc. And this viewer contains 2 types of tools. Sea level, a tool which describes the sea level rise effects. And in this tool, we use profiles selected along the study zone to investigate what could happen in the case of overlapping of extreme events, such as a big storm, with a certain sea level rise. And then we have the shoreline changes. In the last 30 years, a trend can be seen if the coast is gaining sand, is losing sand, is retreating, or is stable. In this background part, we explain more about how do we calculate that and which kind of parameters we use. So first of all, the sea level. The sea level is always on discussion if how big it will be at a certain time period. So there is no consensus on this. We decided to work with 3 scenarios, 0.5, 1, or 2 meters. Then is the return period. The return period is a useful parameter when it comes to assess the probability of an extreme event to happen. So we work with 2 return periods, 1 in 100 years and 1 in 1,000 years. It does not mean that one event will happen in 100 years and then we wait another 100 years to happen again. It means that in 100 years, for each year we have 1% probability for that event to happen, regardless when it happened last time. Then we have the current state, of course, of the beach. Is this the red line here in the beach profile in the picture? And what happens with this beach profile if we have at a certain moment an intense hydrodynamic forcing due to the storm, which overlaps with a certain sea level rise? To characterize better what can happen, we use the regime impacts proposed by Salinger in 2000. And there are 4 of them, and I briefly describe all of them. So first of all, you have the Swash regime, when during this extreme event, the dunes are attacked, sand is lost, but not in a significant quantity. So the dunes are very solid, they withstand the storm, is no problem. Then the second possibility is the collision regime. In this situation, we have significant erosion, but still the dunes are able to withstand this extreme event. So they are resistant to erosion at high levels. Then the third regime is the overwash, when we have the possibility that a row of dunes or all of them can be breached by this intense storm. And then we have the 4th regime, which is the worst of them, is inundation, when all the dunes are wiped out by this overwash flooding and the water is freely flowing into inland. We base our calculation on the Bruin rule, which is a well-known rule in the engineering, coastal engineering world, And this rule describes the retreat of the beach profile in function of the shape of this beach profile, of the hydrodynamic forcing, and the water level. Then we have the tool of the shoreline changes, where, as I said, the evolution of the shoreline position at a certain location is shown during 30 years. So the blue dots show the position of the shoreline with respect to a landmark reference. But as you can see in this picture, this is not a very uniform position of the momentary position of the coastline. But then if we draw a trend, we can easily see if the status on the long term for that coast is accreting, stable, or eroding. If we move to tools, we can look first at the sea level rise effect. So then we have few options. First of all, to choose the return period, let's say 100 years, and then a specific sea level rise, let's say 1 meter. And now we have to focus on the location. We have 6 profiles on the study zone. So we can select one of these to see what can happen during an extreme event. So we select, let's say this one in Netherlands, and then we can display the information. So for this, we have the current situation. This is the beach profile. Idealized, of course. All these beach profiles are having a degree of idealization for a better illustration. They are not meant to calculate the precise erosion and the probability of flooding, but they are meant to illustrate what can happen in the case of the weak coastal dune system, or of the bed management, or other situations. So in this case, with these conditions, we can have a collision regime. So dunes are able to withstand that event, and there is no problem. But if the sea level is rising, we can move to overwash regime. So some breaching is possible. In this case, only the first row of dunes can be breached. So the water can reach farther into the dunes. There is not an evidence that all the dunes will be breached and the water can flow inland. In the third tab, background and parameters, we show again the regime types, but also the parameters that we use for calculation and the parameters that we derive from calculation, such as storm surge level, beach slope, dune retreat, maximum run-up height, offshore wave period. Now, if we move to the other tool, the shoreline changes, here we have all these profiles along the study zone, and they are shown by different colors, and different shades of green means that the coast is advancing. Yellowish, whitish is stable, more or less, and then red is retreat. So if we select a point, let's say here, where the dunes are, where the coast is healthy, so we can see that it's gaining sand. That's probably due to the nourishments that we perform there very often, but also the vicinity of the harbor. We see that the beach is in a good state. The trend is positive, is gaining sand, but it's not always the case. For instance, we have also this red profiles where the coast is losing some sand. Of course, if we have green or white, we are confident that the coast is in a good state, but if it's red, we are unhappy and we think it's erosion. It's not always erosion, it can be side effects because of the human activities, such as expanding of a harbor or dredging for navigation, etc. Many works that have been done in the last 30 years in order to facilitate economic activities. Now, if we move to the data tab, we see 2 types of data. First of all, layers of interest for the coasts. So these are regarding mostly the morphology and the meteo-marine parameters. For instance, the bathymetry, the study zone, By just clicking this eye, you can display or not a certain layer. Obviously, we don't want to display all the layers because then the picture becomes very crowded and it's very difficult to see something. So it's better if you push one at a time. Then we have also a small icon here, a small arrow, which allows the user to download the data that he or she might find interesting. So I display here the bathymetry, and these general views are quite useful because it gives you a feeling about the whole area. For instance, there is a common belief that the Belgian coast is very similar with the Dutch coast. But if we look at this the bathymetry of this area, we see that there are clearly differences between the coasts. Namely, these sandbanks, they are much more developed in front of the Belgian coast and less developed in front of the Dutch coast. Obviously, this kind of configuration of the shelf will influence a lot the development of the coastal system on the long term by influencing the wave climate and the sand supply and other things. So this global view, it's always interesting to look. Now, if we look, for instance, at the shoreline changes, we have again these profiles, but this time with the legend, which helps you again to have a general picture of the coast in the study zone. So different shades of green indicate different rates of accretion, and different shades of red, different rates of erosion. So this is also useful tool to have a good overview of the status of the whole area. Other things such as tidal range, for instance, is displayed as dots. So the tide is not displayed as a continuous layer, but more like dots, and darker is the dot, larger is the tidal range. Of course, this is an important parameter for the development of the coast, the tidal range. That's why we thought it's important to be put here in these data layers. Now, moving on the marram grass related research, we have a lot of research done here. I won't go in detail for all these layers, but let's look at one of them. For instance, marram grass cover. I will go to a Belgian site because this marram grass is not everywhere. But where it occurs, it was investigated. So I want to see what is the distribution, what is the cover. And with different shades of green, we can see if the cover is consistent, such as over 75%, some parts are, or it's like average, or it's below 25%. We can also look at the distribution of the marram grass. How it is spread, is homogeneous, is random, or is clustered. In this case, it's clustered. Then how is the vitality of this marram grass? So greener it is, more green are the shoots of the marram grass, which means that the marram grass is able to reproduce, to spread, and it's basically a healthy system of marram grass, which also helps the other parts of the ecosystem. So that was presentation of the Ender viewer. Of course, there are many more things to investigate in this area. The best thing is that everybody who is interested can take a look, just go to the viewer and explore it. If you find difficult to navigate to it, we prepare a tutorial movie that's on YouTube. My colleagues will provide a link. And using that tutorial, you can explore by yourself. And of course, we are here to reply all your questions and comments if you have it now, or if not, you can contact us later. Thank you very much.